Good afternoon. In our video today, we're going to go through the IXL assignment of K8S, common monomial factors, K8S. We look at our first question here. It tells us to find the greatest common factor between 10j to the cubed and 3j to the second. And then we need to write our answer as a constant times a product of a single variable raised to an exponent. When we see problems like this, we are going to find both the GCF, greatest common factor, of our coefficient, so our number, and our variable, our letter. So first, let's look at our coefficient, our 10 and our 3. If you're relatively familiar with your multiplication facts, you might be able to get some of these greatest common factors, in your head. But if you have some that are difficult, remember that you can write them out to ensure that you really are picking the greatest common factor and not just a common factor. So to do that, there's several different methods. You can list them out. You can do a factor tree. I personally like to do a factor tree because when I think of my factors, I think of them as what they're being multiplied by to get that number. And so that just, works better for my brain. So if I break down 10, its factors are 1 and 10, 2 and 5, and then that's it. If we break down 3, its factors are 1 and 3. Well, what is the greatest factor that they have in common? What is our GCF? In this case, it is simply just a 1. So when that happens, of course, there is a GCF. There's a GCF of 1, but everything has a common factor of 1. So when it has a GCF of 1, it's, just not much. So now we need to look and see what our GCF is of our variables. And I'll, explain a little trick that you can use with these, but first, let's kind of break it down. Similar to our numbers here, if we break down j cubed in expanded form, that means j times itself 3 times. And then our second one is j squared, which means j times itself twice. To find the GCF of variables, we want to see how many how many variables do they have in common? And I can see they both can get up to 2 j's. They both have a max of 2 j's in common. Therefore, 2j's, otherwise known as j squared, is our GCF. Now, to reveal that little trick, and I'll go over this and obviously more examples, but whenever you're trying to find your greatest common factor of variables, it will always be the one with the lowest exponent, because this lowest exponent is the most that it can give, therefore it's the most that it will have in common with the other ones that are larger. So the GCF between 10 and 3 is 1. The GCF between j cubed and j squared is j squared, meaning the GCF of these two terms is 1j squared. But of course, whenever our coefficient is a 1, we don't have to write it. So we can just do j squared. And as soon as I click in the box, this little button comes up for me to do my exponents. So we'll type the j, go into exponent mode, and the 2. All right, let's do another one here, okay? So we want to find the greatest common factor between 2w and 10w cubed. I'm going to show my work for these. Of course, depending on your comfortability with your multiplication facts and knowing your factors, you might be able to get a little bit quicker and do more of this in your head as you gain practice, as you get better and get experience. So we want to find first the GCF of our coefficients, so our 2 and our 10. If I find my factors of 2, it's simply 1 and 2. My factors of 10 are 1 and 10 and 2 and 5. Meaning the GCF, the greatest factor that they have in common, is our 2. So I'm going to go ahead and write this over here. So the number, the coefficient version of our GCF is 2. But we can't forget about those variables. We need to find the coefficient of our variables. So for the first one, for W, we just have one single W. But for W cubed, that's 3 different W's. So what is the most that they have in common? Well, the most that they both are each able to have in common, that they both can give, is just one single W. If we relate that back to that little trick that I told you, this matches up again. The smallest variable, so the variable with the smallest exponent, will be your GCF. Looky there, that matches what we said our GCF was, giving us a GCF for these two terms of 2W. All right, let's jump it up a level. All right, here we have 3 different terms that we want to find the GCF in between. Even though we have 3 of them, the process is still the same. So when I look at these, we're going to start with our coefficients first. So our numbers 8, 4, and 16. The not my GCF, the factors of 8 are 1 times 8, 2 times 4. We can't do 3, we can't, and then we've already done 4. We circle on back to 4 times 2. All right. Factors of 4 are 1 and 4 and 2 and 2. And then 16, 1 and 16, 2 and 8. 3 doesn't go into it, but then we have 4 and 4. All right, we got a lot more numbers to look at here, so be careful. Let's find the greatest one they have in common. They don't all have a 16. 2 of them have an 8, but the 4 doesn't. But they all have a 4 in common, giving us a GCF of a 4. Now let's find the GCF of our variables. For our first term here, we have a squared, which would be a times a. Ooh, for our second one, I have none, so no a's. And then for our third one, we have a squared. Do they all have an a in common? They don't. That one term right here, this 4, does not have the variable a, so it doesn't have any in common with the other 2. Therefore, this is one where there is not a variable component to our GCF. Our GCF is simply just 4. So that is the one little caveat, I guess, to that trick, is if you have a constant, so you have a number without a variable, then there won't be a variable GCF because it doesn't have any in common. It doesn't have any to contribute to the rest. All right. Whew, that's a lot right here. Let's try this one. We have some larger numbers, still the same concept, but our numbers are getting larger. All right, we need to find the GCF between 42, 29, 44, and 45. So when I get larger numbers like this, I kind of work my way down. I always start with 1. We have 1 and 42. And then I say, okay, can 2 is 42 divisible by 2? Or another way you could think of it is 2 times something 42. And it's an even number, so I do know that 2 is going to work. It would be 2 and 21. Then I see, all right, does 3 work? It does. It would be 3 and 14. Does 4 work? Nope, I get a decimal. 42 is not divisible by 4. I know it's not divisible by 5 because that has to end in either a 5 or a 0. How about 6? Yeah, 6 times 7, and looky there, that loops me around. So 29. We have 1 and 29. It's an odd number, so 2's not going to work. How about 3? Nope, 3 doesn't work. 4 doesn't work. 5 doesn't work because it doesn't end in a 5 and a 0. 6 doesn't work because 2 and 3 don't work. How about 7? Nope, 7 doesn't work. Neither does 8. And neither does 9. All right, just stuck with a 1. Let's go down. I'll change my colors so this doesn't blend too much. Let's do 44. We have 1 and 44, 2 and 22. 3 doesn't work. We have 4 and 11. 5 doesn't work. 6 doesn't work. 7 doesn't. 8 doesn't, and neither does 9. And then 45, 1 and 45, and then 2 doesn't work. 3 does. 3 and 15, 5 and 9, and that's it. So what's our GCF here? It's just 1. Now, can I tell you a secret that I'm wondering if maybe some of you figured out? Once we got to this one right here, 29, and we realized, there's nothing else that works with 29. And 42 did not have a factor of 29, so that kind of tells us that means this is going to have to be our GCF, because if my first number does not have a 21 in common, therefore the only 2 things these have in common is 1, meaning the only thing it's going to have in common between all of them is going to be 1. So sometimes you might kind of figure it out a little early, but of course, if you're taking a test or you don't want to lose a SMART score point, you can always be safe like I did and work them all out. Now, when we go to our variables here, my 42 doesn't have a variable. My 29 has a single z, my 44 has z to the 5th, and my 45 has z to the 5th. Well, if we think about that last problem we had, if we have a constant, if we have a number without a variable, they don't all have a variable in common. Therefore, they don't have a variable GCF. So this is one where we simply just have a GCF of 1. It seems like an odd answer, but it is possible that your GCF can literally just be 1. All right, so the other type of problem that you're going to see on this IXL assignment is when you need to actually factor out, or you need to find the greatest common factor of a polynomial. So notice here that they're not listed by commas, they're listed by those plus and minus signs, okay? Now, when you work with these, as you can see here, this is a different problem. I wanted us to start with a smaller one. For this assignment, it's not really any different because we're not being asked to actually factor the GCF out, which is something we are going to be learning. If we look at the directions here, we simply just need to still find and identify the GCF, okay? So we're just finding that GCF. It's just writing it as a polynomial. So when we have multiple terms all being added or subtracted together, that has an extra special name of a polynomial. So I'm going to treat this like the others. We're going to look at our coefficients here. We have 8 and 18, and that's a bad one. And we need to find the GCF between those. So for 8, we have 1 and 8, and 2 and 4. For 18, 1 and 18, yikes, struggling with my 8s today. 2 and 9, and then 3 and 6. What would be our GCF here? The greatest thing they have in common is a 2. Now check out our variables. We have n to the 4th and n squared. So if you need to list them out, that's totally fine. We have expanded form, we're multiplying 4 n's. And then for the second one, expanded form, we're multiplying 2. So the most that they have in common is 2. Another way to look at that is you see which one is smaller, because that's the most that they're going to have in common, and that would be 2. So n squared is the second part of our GCF, 2n squared. Perfect. Let's do just a couple more problems and then we will end things here. This is a good one. So this is one that when I look at it, I'm able to do it without listing out my factors. But again, I've had lots of practice. So you may be there, you might not be there yet, and that's okay. I've had several years. I'm getting to be an old lady here. So that's why I've had all the practice. But we have 3f to the 4th, 3f squared, and 18f to the 4th. When I look here, I'll kind of walk you through how I'm able to see the answer quickly. I notice my coefficients are 3, 3, and 18. Well, 3, I know, only breaks down into 1 and 3. And then we have a second 3. They both have a 3, that's in common. And then can 3 go into 18? Yeah, 3 is a factor of 18. So that tells me, all right, the number part of my GCF must be 3. And then for the variable part, I have f to the 4th, f squared, and f to the 4th. They all have f's in common. So therefore, I will have a variable GCF. And the smallest one is the most that they all have in common, the most that they all share, which would be f squared. So that is how when I have smaller numbers, I'm able to kind of look at it without listing out the factor pairs for every number. Just a little tidbit in case you wanted that. All right, let's go ahead and let's make this actually, let's go up to a little higher level to do our final problem. Yeah, let's make this our final problem so we can do a second one where it's listed as a polynomial. But remember, for the purpose of this assignment, because all we're being asked to do is find and identify that GCF, it doesn't matter if they're listed as separate terms with commas or listed here together as an expression, as a polynomial with plus or minus signs. So we have 21, 28, and 7. I'll go back to listing out the factors for this final one so you guys can see all the steps. 21 is 1 and 21. 2 doesn't work because it's not even, but 3 does. 3 and 7. All right, 28. 1 and 28. It does work by 2. 2 and 14. It doesn't work by 3, but it does by 7 and 4. And then for 7, it would simply just be 1 and 7. So what's the GCF that we have in common here? 7. Now, a little trick. is if you have a problem like this, where you have two larger numbers and one smaller number, see if your smaller number is the GCF. It won't always be, but that might be a faster way to check things out. Say, okay, 7 is clearly the largest of this. Can 7 go into 28? Yepers. Can 7 go into 21? Yes, it can. So therefore, we have our GCF. There's another little trick. Now for our variables here, we have f to the 7th, f to the 5th, and f to the 4th. So remember, with our variables, we look for the smallest one if they all have variables, which they do. So there is a variable GCF, and f to the 4th is the smallest, therefore that's the most all three can have in common. Good grief, I clearly need to end the video. I can't write anymore. Leaves us with a GCF of 7f to the 4th power. All right, it's your guys' turn to try this assignment. I believe in you. Good luck. Use that notebook paper, or remember, on IXL, you can grab this pencil tool and you can write on IXL with a writing tool or a highlighter, just like I did on my screen here. You may not have as many colors because I used Zoom to write, but IXL has a couple options, so it's still good if you prefer that method over paper and pencil. All right, if you have any questions, make sure to reach out, but I think you got this. See ya.